Here we have a problem of Claisen rearrangement. So here we have a allylic vinylic ether, but we're being asked here to give a mechanism to form these phenyl from this molecule. So we know that we have rearranged. Now the atoms are organized in a different way. So let's start doing that. And the idea, this is in this rearrangement, we need to be drawing the molecule to form a cyclic transition state. So this happens in several steps. So I'm going to redraw this molecule above, but now I am going to rotate this like so. So notice I have, I'm going to grab another marker. So here. This carbon, that is the allylic portion, right? And here I have metal. Now, that's my original molecule. Now it is in a cyclic form. And I know that I'm going to be breaking the bond here at the allylic side of the allyl vinylic ether. So next step will be, I'm going to be drawing my arrows. This bond is breaking, and I'm going to be forming a double bond, carbon-oxygen. This bond breaks, I'm going to form a sigma bond here, and now moving those electrons, I'm making a double bond there. So let's draw the structure that results. And let's remember that we have these two metal groups. So now here I have made this new bond. And here, double bond, that. And I have noticed 1, 2, 3, 1, 2, and 3. That's molecule. We're not there yet. So we need to do another rearrangement. For now, let's remember that this rearrangement Claisen is 3, 3. So 1, 2, and 3, and 1, 2, and 3. Now the new sigma bond is formed between carbon 3 here and carbon 3 on the other end. That's what we did. Now notice that now this group is at the bottom. We cannot do the tautomerization step we did before because this is a metal group. In a previous problem, we had a hydrogen here and we had produced a phenyl. So now, since we have that group over there, we need to propose another rearrangement. So this is now from here, I'm going to redraw the same molecule. And now, this stays the same. Now, this, I'm going to do 1, 2, and this now. And I have the metal. Now again, the bond that is going to be breaking is on the allylic side. That is my allylic group. So this is the bond that I'm breaking. And so I'll be moving them. Those electrons, this bond break, this move over here, this move over here, and that over there. And so the product after that rearrangement, notice, let's do the numbers so that we remember how we do that step. It was the bond that breaks, this is 1, 2, and 3. The other side of the bond that breaks, this is 1, 2, and 3. So I'm proposing another 3, 3 Sigmatropic rearrangement. Now this rearrangement right here involves the oxygen. It is the type of ether, allylic vinylic ether. So that's a Claisen, but here that is a 3-3, but that's actually Cope. It didn't involve the oxygen. Now, let's draw the molecule that results in. Now I'm going to be erasing that to have room to draw our product from this step. So let's make it smaller here. Now I have that, that side stayed the same, and I have this. And I need this one. All right, so, but now I do have an H here. This is not yet the product. This is our product. We're getting closer to that. Now, what we're going to propose, notice, is that I need an H over there. Now we're going to propose another rearrangement. This time I'm going to be breaking the bond here with the hydrogen. And let's say this is, we're naming the ends of the bond that breaks with number 1, so 1 here. And let's see, 2, 3, 4, and 5. So if I do that rearrangement with, say, that migration 1, 5, I will get the final product. So from here to here, that's a 1, 5 Sigmatropic rearrangement. So we had 3 rearrangements to go from this product to, from this structure to the final product. First, again, we have a Claisen rearrangement, so the typical allylic and vinylic sort of ether. But here we could not do the tautomization step we did in a previous problem because here we have a metal. So what happens is that, again, you rotate the chain so that you make a cyclic transition state, so you have another rearrangement. This time is 3-3. We have put the numbers here to recognize that this is a 3-3 Sigmatropic rearrangement. And after that, we get this product, which is not yet aromatic, but if we do a rearrangement 1, 5 with that migration of the hydrogen, we get our product, which is aromatic. And of course, that rearrangement is product favor.